Subscribe, like, and share. Time is something we experience every day. We measure it with clocks, calendars, and the movement of the sun across the sky. On Earth, time seems constant and the same for everyone. However, in space, and at very high speeds, time behaves differently. This surprising behavior is explained by the scientific theory called theory of relativity, developed by the famous physicist Albert Einstein in the early 20th century. According to relativity, time is not absolute. Instead, it can change depending on speed and gravity. The theory of relativity is divided into two main parts: special relativity and general relativity. Special relativity, introduced in 1905, explains how time and space behave when objects move at very high speeds, close to the speed of light. General relativity, introduced in 1915, explains how gravity affects space and time. Einstein proposed that space and time are connected together in a concept called space-time. Instead of being separate things, they form a four-dimensional structure that describes the universe. Massive objects, such as stars and planets, bend this space-time structure, and this bending affects how time passes. One of the most fascinating ideas in relativity is called time dilation. Time dilation means that time can pass at different speeds, depending on how fast an object is moving or how strong the gravity is around it. If a spacecraft travels very fast through space, close to the speed of light, time on the spacecraft will move more slowly compared to time on Earth. For example, astronauts traveling at extremely high speeds might age more slowly than people on Earth. This means that when they return home, less time has passed for them than for the people they left behind. Although this effect is very small at normal speeds, it becomes noticeable when objects move at extremely high speeds, such as particles in accelerators or spacecraft traveling through space. General relativity shows that gravity also affects time. The stronger the gravitational field, the slower time passes. This phenomenon is known as gravitational time dilation. For example, near very massive objects like black holes, time slows down significantly. If someone were close to a black hole, time would move much slower for them compared to someone far away in space. A few minutes near a black hole could be equivalent to many years on Earth. Subscribe, like, and share.